Hello and welcome to Live Coding with Gerph. Today we are looking at the sprite rendering for the WindowManager, which is going to be, well, I'm hoping it'll be interesting. We've got some Python code already that does this, so we're going to have a look at that. And all being well, we should be able to get through a good chunk of, well, a little chunk of it. I don't know how many weeks this is going to be, probably 3 or 4, I imagine. Oh, right. So, as you can see, we've started out with a blank canvas, which is always a good place to start. So, all going to be going well. And yes, I've got a camera. We've got the poor camera today rather than the decent one, because the other one is still not playing ball with me. And I need to reboot, and unfortunately I've got AI doing a bunch of things, so I don't want to do that. Yes, I have remembered to put the t-shirt on. This is always a good starting point, isn't it? Okay, so yeah, this is where we left off. We were looking at the utility module, Stargos. So that is now done. So next thing for us to do is to go and create a new project. Let's create a new one. I hope people have seen the exciting, thrilling, and well, shorts that I've been videos that I've been doing. Those have been interesting to do, and we've got Alan and Andrew and Talia here as well. So we've got a few people. Yeah, so the videos have hopefully been showing people how to do things. So a lot of what I'm doing now, if you've seen those, and you've seen some of these videos obviously, will be pretty familiar. So this is going to be Viscos Wimp Sprite Render. Sprite Render, is that the right one? No, text. No. Did I call it text render last time? It already exists, so if the other one is called text render, then we'll call this one sprite render. Awesome. Viscos implementation of the sprite rendering code to go into the WindowManager. Public and create repository. There we go, we got it. Now we come over here and we go and create the directory for it. So make a directory, Viscos, oh, I've already forgot what I called it. Wimp Sprite Render. It's important for me to have like a consistent naming scheme, both on GitHub and in my own repositories and in my directory, because I have a lot of things in here that are not especially well named. But there's obviously a lot of ones that are public that have all got their own labels there. So that's why I try and keep these namings relatively consistent. If you check any of the things in GitHub, you'll find a mix of these Viscos and Viscos 64 things. And mostly the 64 is targeting just 64, and the plain Viscos ones are targeting probably 32-bit, but almost certainly, no, certainly both, but probably 64-bit as well. Yeah, so that's that's what I was doing. So we're in there now. So Viscos Sprite Render, that's the one. Nothing in there. Good. Create a new repo, and we'll set the remote to be. In fact, we'll just use this command here. Copy that command, paste, do it. Yay! All right. So the usual thing we do, as you'll remember, is we go and just create some skeletons. So create module, not vtrap. We'll call this one sprite render, I guess. There we go. Oh, except I don't want to create a module for it initially, do I? I want to create a plain commands, because that's where we start out. We start out by creating a command, and then we move into making it a module later, because it just makes things a whole lot easier. Right. So we now have that. Let's just status that. We can see the, sorry, yes, there's the files. Add C version make file. Thank you. And then we'll just build it to make sure it works. Project AMU rather. There we go. Dev common command is AAF32.wimp sprite render, just to prove that what we've built has worked. Thank you very much. And then we can go and add, commit those. Stub command line tool to start our sprite rendering code. Oh, just a stub from Viscos projects. And we can then push that and it will then turn up over here. Reload. Ta-da, magic files. Now we'll just go and create the remaining bits. So as we saw in the, hopefully you saw in the videos, we create the Git management code, PR management code, CI management. Thank you. And what's it on? License, emit. And then obviously we have to edit the license as well. There we go, just change that so it says 2026 me. There we go. And if we have a look now, we'll see a whole bunch of files. Git add, git attribute, git ignore, git hub, oh, git, and one's there. Git hub, code owners, and license. Oh, we probably should create a README as well, just a stub to do this. So this is Viscos Sprite Rendering. Placeholder README for the sprite rendering for the WindowManager. There we go. Add it. And then push. Oh, commit. Yeah, it helps if you commit the code. If you don't commit it, it doesn't push anything. Right. Added all the other maintenance files for GitHub, GitLab. Maybe I should do a Viscos project minus all. It just creates everything for you. I suppose I could just wrap it in a shell command as well. Right, so let's push that over here, and when we reload the page, what we should see is all the files there, a little bit of that, some MIT license, and it's running its tests, which are in progress. There we go, it ran and it was successful. Whee! All good. Pretty nice, really. Okay. So we now have a basic skeleton. Now we've got to actually do some work, because all that was just boilerplate stuff. Just makes things a lot easier for us to start out with something. Oh, I forgot to add the GitLab ones. Add GitLab. Sorry about that. I'll just amend that to the commit we just did, since it's just an addition of a file. There we go. And we can push that. Force and update. Oh, we already did that. Okay. So yeah, there we go. We'll just see that that's got an extra action that's done that one. So one of the nice things about this, in case you've not noticed, is that it goes and builds and runs it, and it only takes 6 seconds to do that. So we basically get a result back before we've even had a chance to jump to the browser, which makes things a lot nicer because we can get feedback more readily whenever we need it. So let's have a look at what we're actually going to do. Let's pull up the code. So edit this. Here we are. Yeah, let's put it in the right window. And as you can see at the moment, all we've got is a very simple main file without my name in it. Let's just shove that in there. And now we're going to want to start writing some code for the sprite rendering. So normally what we would do is we'd come over here. Oh, it's horrible. Hasn't been fixed yet. So GitHub changed everything so you can't style your diagrams anymore. So they all look naff, which is a bit sad. It's very sad. So I'm going to have to do something about that. At some point, I haven't got round to it. Like everything else, it just takes time. So we want to do sprite rendering, and I think sprite rendering is in 3. I think it's in phase 3. Only got 8% done in here. Wimp Sprite Rendering. But as you can see, we don't actually have a file to tell us what we need to do here. So we're going to have to work out what is needed for this. And the easiest way to do that is pull up Pyro. Not the AI stuff. We want Pyromaniac, Riscos / PyMods, Core Wimp, and we want. Ooh, where is Sprite? Ooh, oh, hang on. Do we not have a Sprite? But did I not separate it out? Oh, that's irritating. Right, let's have the whole Pyromaniac Riscos pulled up, because then it's not going to be quite so big. And we'll just have to have a look at that. Let's see then. PyMods, Core, Wimp. So if it didn't split it up, it must be in Wimp Graphics then. Bounding boxes, Wimp Sprite. Here we go. Operations on Sprite in the Wimp. And then a general graphics context, which is essentially what G context is, which we've got all sorts of things here. Yeah, here we are. This is quite nice. Text sizing. Yes, I went and made this all quite general, didn't I? So yeah, let's just go through what we've got here. So a bound stack. So this is an object that it knows what the current bounding box is on the screen, what we're clipping to, and it can go and apply the clipping to it. So you can set what the clipping rectangle is, the full width, height, and things. You can create a new one. So you push the contents and create a new stack of them. So basically, you can say, I know where you were, but now I want to render this bit, and that bit can be outside the region. Andrew says, no GL surfaces to render to. What is this? Riscos? Yep. But the idea of this is we should be able to try and abstract some of the video and rendering things in the future. That's the sort of thoughts that I have in this, at least from the Python side. Whether we can do it in the C side, I'm not sure. So yeah, that's what we try and do there, and then we can actually apply the bounding box by applying it to the graphics context. We've also got these the sprite objects. This is what I want. I've got a Riscos object, a graphics object, which is something that's further down, an actual sprite that we want to render, and then the different properties, whether it's half size, whether it's unscaled, whether it's literal, selected, or shaded. There should also be highlighted as well, but for now we've just got those. And then we also need to know the window background and what the current selection color is so we can do it properly. And so we can actually go and plot those. We can read the size of the sprites. We can go and get scalings to go on the screen and get some pixel translations. But this is all stub code. It's not actually doing anything at the moment. As you can see here, we're reading stuff from the sprite and we're reading stuff from the graphics renderer. And this is the graphics object I was talking about. The graphics object has some bounds on it. It knows what the screen size is. It knows the sizes of pixels. And it knows what the environment is, so it can go and reset things completely. It has some calls that do rectangles and clip text, plain text, working out the size, plotting some symbols, which are these symbol constants here. So that's how we plot the symbols that are going to be on the furniture, like the tick icon and things. So these are semi-magic at the moment. They're just like, I want to plot one of those, just make it happen. This is for resolving a sprite, looking it up in the different sprite pools. Because if you've got a window, then you need to look at the sprite pool that's present for the window itself, and then you switch to the Wimp's sprite pool. And the Wimp sprite pool can be priority pool, regular sprite pool, and WindowManager pool, or you can have those two swapped around. So there's a little sequence of the how we look up sprites. So resolving sprites does that job. Sprite size will create an instance of the sprite and then get us the size of it. And then there's actually just getting the sprite itself, so we can actually operate on it. And then this is the Riscos version of it, so it uses Riscos operations. And the idea here is all of this class here is what you need to implement to provide the rendering for the Wimp. But it doesn't have to be implemented through Riscos operations. See here we're doing ColourTrans operations and some color map functions and things like that. But it could be implemented, as Andrew says, using OpenGL. And then you could run the same code, but on another system. Or you could have your OpenGL implemented on Riscos, and then you could do it there. That is the idea of what we're trying to do here, is to separate out the different parts of the functionality. So you can see here this complex render function that just goes, yeah, render, is it tiled? No, do it this way, that way. And then there's some more, hang on, that one, yeah, that's a Wimp, oh, that's a Wimp Sprite render operation, sorry. Yeah, that's a sprite, that's overloading the sprite one with Wimp operations. And this one's overloading the graphics operation. So this is saying, these are the character definitions, the VDU23 codes that we would use to define those. And these are the different things that we need to do on startup. So here we're finding where the textop codes are. So textop is essentially the Wimp textop SWI call, which is the things we implemented a couple of months back for text rendering. And this one is finding the Wimp Sprite pool, which is a concept we will come to later, but this is basically a way that we resolve through the priority user and ROM sprite pools. Yeah, priority, yeah, that's right, that's the ordering we've got. There's some additional functions here for internal things, setting the environment and things, resetting things back and stuff like that. And then our little rendering stuff, so moving, drawing, here's our rectangle fill. All this we can implement through G-context, nice and easy. Rectangle rendering, that is an outline rectangle. Text rendering, blah, blah, blah. Text size, just calls textop calculate size, which if you remember the textop codes, that was exactly how we did it. Sprite handling, so this will call into our new routines that we're going to use here. All right, and then finally we define this as a Wimp graphics. So that is the general graphics interface we've got in Riscos Pyromaniac for the Wimp, which is not all implemented yet, but there are parts of it that work. So what we're going to want to do is basically handle the stuff that is necessary for Riscos Wimp Sprite here, this bit. And that probably means we're going to have to grab a bunch of other things to get things right. As I've noticed here, we've got Fix Me here saying, yeah, we don't only have a special sprite for a special palette for 16 color modes, we also have them for 2 color and 4 color modes as well. So there's bits here, as you can see, that aren't quite done, but we'll have to do some bits. It's going to be fun, I hope. Right, so probably the best way to start out is with, so this class here that handles Wimp sprites, this is the base class that we're going to want to handle. So let's start by implementing a bit of that. It's not going to be too hard, I hope, because as you can see, it's just data processing. But we're also going to need to put together a little bit of boilerplate code to be able to actually operate on sprites. Oh, I've got great big fingerprint. Put more fingerprints on my glasses. There we are. Doop de doop de doop. Okay, so hopefully I've explained pretty much what we're going to try and do here. There's a bunch of bits, as you saw, that are not present, and we're going to basically stub out, just so they're not actually doing anything. Let's see what we can do. Right, so Wimp Sprite. Let's just create this object, and yeah, we'll get a class that defines this, and we can start putting together something that will handle it. I think that's probably a good way of working. It's possible that we won't use it all in the same way, but let's start with it anyway. So let's have a new file called Wimp Sprite, because this is specifically, oh no, we're not doing a Python file, this is a C file. Right, and the easiest way for us to do this is to just lift it and then implement it in C as we go. We'll see how we get on. Because as we go, we're going to find there's bits and pieces in here that are not quite right, and we need a bit more things implementing. So, oops, no, a bit further to the top. So let's give us a file. This is Wimp Sprite. Wimp Sprite manipulation for the sprite manipulation for the WindowManager. Right, so we're just going to include we're going to need swize.h, and we're going to create a class that manages this. So, oh, and we're also going to want stud-int, aren't we? Because we're going to want to define some values that are all about the same size. Struct Wimp Sprite s Wimp Sprite t. I have no idea if this is all going to work out the same way it did when I did the Python, so we'll see. Let me just make this all green so it's not oddly coloured. And we're going to have a number of objects in here. So we're going to have a Wimp graphics that's going to do most of the graphics context. So what I'll do is I'll create a struct Wimp graphics s, which is a Wimp graphics t. And we'll have a sprite. Oh, do we want to have one graphics for these, or do we want to pass it in to all the operations? Not sure. Yes, we do need to pass it in, because the graphics is also going to hold things like the sprite pool lookups and stuff. So let's associate it here. We can always move it around later. Yeah, so that's what we've got there. This design may not work as I'm wanting to, but we'll see. Oh, stud bool then. There we go. A bool is half size, is unscaled, is selected, is shaded. Ooh, we also want to know the Wimp background and selection color. Okay, fair enough. So that's we'll give that a color, shall we? So we'll call this a color T. Make it a uint 32. So we've got a color T defined in the gcontext code. So we'll probably go and grab that eventually, but right now we can just do this way. So a color T, Wimp background, and then a selection color. Arguably selection color should actually be in, oh no, it can't be in the graphics context, because the selection color might be overridden for this particular sprite. So although there might be one in the graphics context, we need to have one for each sprite as it's manipulated. So that's going to be fun. Oh, and we also want to know the sprite. So let's just create a struct for the sprite as well. sprite S there. That's the sprite we're handling. Okay, so that does our initialization code. Well, actually, we probably should do have a create call, shouldn't we? So there's only going to be one failure out of this, isn't there? So Wimp Sprite create, and that takes a Wimp Sprite T. Oh no, it doesn't take Wimp Sprite T. It takes a Wimp Graphics T, right, and then it takes a bunch of these flags. So is half size as booleans. So we could make these into bit fields, and maybe that's the right thing to do in the future, but let's try and mirror the Python code that we've got, because that will make things a little easier. Selected. Because it doesn't matter at the end of the day whether this is inefficient, because if it's inefficient, then we can start optimizing it and making it better. But if it doesn't work, then that's something we really need to be working. So it's always possible that we can start out bad and we then get better. Right, and all this is going to do is, I've missed something, haven't I? Yeah, I've gone and got this all confused there. That should be a graphics, and then we should have a sprite T that points to the sprite. There we go. No. Now, yeah, we just want to initialize these, so we want to create a object which is a Wimp Sprite T star W Sprite. Seems like a reasonable name. Malloc size of star W Sprite. Some of those letters are right. If sprite null, return false. Oh no, we can't return false. We've got to return the W Sprite, haven't we? Wimp Sprite. See, sometimes I'm just not sure what I'm doing. There we go. Right, so if W Sprite equals null, then we fail and we just return null, because that's the only failure we can have here. So what we want to do is do, this is going to be easy enough, I think. We grab all of these, put them in here, and then I think, let's see if this works. Jump to the end, go back a word like that. Yeah. Now go back to the start of the line. Oh no, that didn't work. End of line. Back a word. Now go back to the start of the line. Delete that. There we go. W Sprite to graphics. Select the word equals that. There we are. Dun dun. And we have a constructor. So that's the new function call created. So we've got a get size call. Now, as you can see here, we're actually going and just calling into the sprite operation to say, sprite, what is your size? So that's quite a nice starting point for us to have here. So Wimp Sprite get size. Let me cancel those alerts. Come on. Disable for an hour, please. When it pops up next, I need to actually take a break. That'd be good, wouldn't it? Get size, and this is going to, what's it going to do? Yeah, it needs to take a Wimp Sprite T. Yeah, so we take that, and we're going to return a size from that. Now we've got a choice. We can either return it as a struct, or we can return it as into a struct. I'm going to return it into a struct. So this is going to be a bounds T, because it's got a, oh, it's not a bounds T, it's a size T, because it's got a width and a height. Yeah. Oh, that can't be called a size T, can it? Because size T is a C thing. Okay. Or size? No, it doesn't work. Yeah. What should I call that? All right, let's have a look in G context and see if we already have something that I used in there. So Riscos G context. Yeah, there we go. Because if we've already got something in there, we can make it use that. G context. Chords, accords. Yeah, it's a kind of a chords. Bounds is just a width and a... right, that's different. Yes, a bounds and a bounding box. Yes, that's how we defined it. Okay, so I'll just pinch these. I may as well, because we're going to start using this later. But let's not complicate things, so let's just stick these in here. Actually, should I complicate things at this point? Should I start pulling it in now? If I pulled it in now, I wouldn't have to do anything, and I could start getting out some rendering things, couldn't I? That could be quite useful. Yeah, I think I should do that. Yeah, I think we should. Let us do that then. So let's... how did we do it in... Because we did it in the text region, text render, didn't we? So if we compare this against Riscos Wimp text render there, pick this up and put it here. Right, so this is the comparison of those two folders. So we have a look in here. We've got a bunch of functions. Palette handling. Yeah, palette handling is going to have to be moved in here as well. VG5 characters, USG. Right, let's have a look at the make file, because that'll be manipulating stuff. CG cons. Oh, we just exported it. Oh, interesting. Okay, let's use that then. Do that into there, and then that's all we really need. Why do we not have the includes in there? That's confusing me. Surely we need to have the includes in there for it to know where to... Oh, it's in C colon, isn't it? So it's C colon G context. Yeah. Yeah, okay. So that's actually quite easy, just pulling that in there. Which means that since that's going to be in there like that, we're going to need to have some magic in our GitHub to handle that. This one's a bit newer than this one. Obtain the Riscos archive management and the G context library. Let's do that. Yeah, that's all okay. All right, that looks good to me. Close that. And then we also want to update row build, because row build will need to, not row transform, so row build. Here we go. Update C path with the libs we downloaded. Yeah, let's have that. Make the command line tests. That's what we're doing here. And then there's modules and things. Yeah, so it's going to be very similar. Yeah, all right. Let's close that as well. So in theory, that should do the job, I reckon. I hope. Should we ever see? Yeah, let's get something that we can like do something with, shall we? Oh no, that's what I forgot to do. I'll pull that back up again because I need to know how to use it. So have a look in text stop here. Maybe not text stop. Text render. Yeah, that's how we use it. We use that call there. That include. There we go. All right. So now we're not going to need the color T because color T is already in here as a uint32 there. We can start using chords, bounds, and bbox. So this is going to be okay. So we don't need the bounds and we don't need the B box here. We don't need the color T, right? And get size here is going to be a, we're going to call into sprite, whatever sprite is, we don't know yet, get size, because we're going to want to implement this code. We're just going to implement it and see what happens. So if sprite null, then we return, oh hang on, we call this a chords. I'm not sure that chords is really a good name for something that gets a size, but it's okay. If it's size equal size dot x equals 0, so it's bounds. It's a bounds. That's what I decided, wasn't it? Ugh, no good. Bounds t bounds x equals so width equals 0 and bounds dot height equals 0. Return bounds. Okay, and now we get the width and the height. So sprite get size. This is also going to be a thing that returns a bounds. So we actually return it into the size here. Get size of sprite to sprite. Oh no, that should be a W sprite. We should be differentiating them because they're different types of objects. So we get size of that, and we also want to know its eigenfactors. Yeah, probably the easiest thing to do here is to actually set up something that is an int xeig and int yeig for the sprite. Should I return this as a ratio? Should we have a ratio object as well that returns the eigenfactors? Well, that would actually be quite useful, wouldn't it? I mean, strictly, those could just be chars, can't they? Although, something springs to mind. So Dave has suggested CG point, CG size, and CG rect in Apple land for the context for the graphics point, I'm assuming, or possibly a C context for those. I mean, that's not bad actually. Maybe I should be using those names. Maybe I should change that over in G context. Maybe. Yeah, not sure. So what I was thinking was, it was a couple of days ago, may have been yesterday, I've lost track. Dave mentioned about having eigenfactors of -1 to have very high resolution images, which would be good, except that none of the code would understand it, and Acorn just had a... I think they probably assumed, well, we're not going to get up to that sort of resolutions and high resolution displays, and if we do, we'll work out a different way of handling it. But hey ho, that's the way it's gone. For now, I'll create them as this, some eigenfactors t, and we'll do it that way. So we'll do eigenfactor. Oh no, yeah, we can actually define this as... Oh, I'm not typing very well today, am I? Sprite eigen. There. And we can actually do that as s eigen equals I think it's arguable that we could do these both in the same call, because you're going to be likely to need them together. Yeah, we can always change it in the future. Forgotten what I'm doing. Yeah, this bit here, shifts. Yeah, so Dave said it's all based around shifts, so it'd never work. When they introduced the new sprite format, they introduced the different way of handling DPI ratios, but only defined that the standard eigenfactor values were valid. So although it had the capacity to handle more, it would never be used. So it's, yeah, it's one of these things that just could be being sorted out. And maybe this is a way that it can be done by abstracting parts of the code so it doesn't have to handle it that way, and then we can start doing things a different way in the future, maybe. I mean, in 2026, talking about in the future in Riscos is just pretty nuts, but try and think of what the ways that things can be made better later. Yeah, so the whole point of this was so that size.width equals size.width shifted left by sprite eigen dot, what was it called? Was it just xeig? It was xeig. I'm sorry if I'm pronouncing eig wrongly on this. Again, these are just like this is how I've learned to say them. So if anybody wants to mentally translate them or wince every time I say things, that is fine, and I'm very sorry. Height by the y eigen. So this gives us the logical size of the sprite as it's being rendered. And then here we've got, if it's half size, divide it by 2. Well, that's easy enough. If WSprite2 is half sized, size.width equals size.width over 2. Oh, no, it needs to go in braces because it's going to have 2 of them. We're going to have a height as well. So width and height is now our actual height that it's going to be in OS units. All right. Spelling mistake alert. Where? Higgith. Right. So there we go. We've got that, and that's all that function does, I think, isn't it? We just do those things and then we return it, so we can then return size. Okay, there's then this thing here for getting the scaling, which does similar things. Okay. And that pulls in a scaling transform. And then we've got a pixel transformation and a render. Ugh. Right. Rather than implementing all of that, not that there's much here, but rather than doing that, let's get to the point where we've actually got something that compiles and we can actually do something with it. And we know we're not going to be able to do something with it because we haven't implemented these functions. So what we'll do is we'll just do some stubs here. Stubby. Stubby. Is that how you spell stubby? Not sure. Oh, they return structures, and these take sprites, don't they? So it's sprite t star sprite. Both of these just return an object, or 0, 0 for now. So this one is going to be returning a bounds t. Bounds t. Bounds, didn't put enough things in there. And this one is an eigenfactors, which is an eigenfact. One of them. Come on, thank you. Eigens. And then return eigens. Return bounds. Alright. Oh, and this one needs to return an eigen. Right. One interesting thing is using this way of referencing them and returning them as objects is actually really inefficient on Norcroft. Reasonably inefficient. We could return them as pointers instead, but this just makes things a little bit easier for us to handle, I think, anyway. It's possible I may have to rewrite it anyway when we try and compile it. So what do we have as external functions? This is an external function called Wimp Sprite create. Create a sprite object for rendering or sizing. Graphics points to our Wimp graphics context. The sprite we are rendering is half size, is unscaled, selected, is shaded. Properties for the render. And then window background, they're also properties for the render. Returns pointer to a new renderable sprite object. And this one is going to get the size. Wimp Sprite get size. Retrieves size of the sprite we are rendering. The sprite points to the sprite data, sprite information to render, and returns a bounding box. Oh no, a bounding box, sorry, about a width and height and bounds. So something going on here. They're suggesting that I'm checking if you're paying attention by putting mistakes in there. Yes, I'm. Yeah. I'm just not able to write. That's all. Okay. Get size. Right. So we've got those. Let's go and put those into a header. New folder. H. Oh yeah, and then create a file, don't we? Called Wimp Sprite. Yep, there's not a whole lot of actual rendering here, but we will get to this. It may not happen this week though. There's going to be a bunch of boilerplate to sort of set up what we need to do to be able to get there. And as you can see, because I'm basing this on the Pyromaniac based code, we know that the mechanism works. It's just whether it's going to be the right choice for C, which it might not be. No, this is a file I'm defining. Actually, if it's a file I'm defining, I can just go back to here and copy the file prologue from there. There we go. There we are. Include stud bool. Oh, and I've got some other types in here that I need to just stub in here, don't I? So I need to move the stubs out from here. In fact, all of those need to come out of here and go into the header. And then I want to do the usual thing for the header of guarding it. Sprite. So one of the other things that you may notice with these implementations is that I am not implementing any parts of the assembly version of the code. It's just not looking at it at all, just knowing what the routines are going to do, because that's what would be needed, and we'll implement it. And it's only when we come to some corner cases or something that's odd that we'll look at the assembly code. And that's kind of important, because it means that you're not being too biased by the whole how the assembly code was written and how it was optimized and made specific to handling in a rather old CPU, because it was all designed for ARM2 basically. Yeah, I have two endifs. Yeah, thank you. Yeah, there we go. So I've got bools, I've got sprites defined, I've got color tees. Oh no, I haven't got color tees, because color tees are defined in here. So they need to go into there. Right, like that. So let's have a see if we've actually can build this. We need to add in the o.wimp sprite in here, and then we can build it. Viscos ammo. This will almost certainly not work, but yeah, that was not great, was it? So that at the beginning usually means I've forgotten a semicolon on things. Oh no, I haven't. All right, what does it mean then? Damn it. Bounds T hasn't been defined. Well, it's over here. Look, I defined that. Oh, yeah, except I didn't include our Wimp Sprite.h. Excuse me. Oops, studlib. Okay, move that up. Oh, hello, Cool Studios Unity. Hello. Welcome to C coding to implement a WindowManager sprite renderer. Wimp background, bounds. So those two, 62 and 61. Does that mean I didn't pass them in? Wimp background, window background. Yeah, that's what I did wrong there. So let's replace Wimp background with window background in there. Selection color is the same. I need to do it in the header as well. Just do that replacement there as well. Okay. Oh, itchy nose. And we're in bounds as well. Where did bounds go? What's that? That's at line 81. Oh, because it's, I call it a size. I'll call it a bounds then. Then it'll work. Inventing, yeah. In some places I've called it a size, and in some places I've called it a bounds. Oh well, we'll just fix this up. Bounds. Keeping the name of the object and the name of the type the same is actually a pretty sane idea, isn't it? Bounds. Bounds. There we are. And then finally we've got a cast a non-equal structure because it's invented it, that's why. Inventing int sprite at line 85. Oh, because it's W sprite there. Oh, and bound I've done wrong as well. What's that? 88. Bound. Oh, it should have been bounds, not bound. There we are. Okay. Do. Has no higgets. Done it again. Thank you. I'm sure somebody pointed it out and I missed their note. Hang on. H-E-I-G-T-H. How do you spell it? Oh, there, that one. That's how. Oh, I misspelled it. God, blind, aren't I? And I've got another one there. 89. It's HT. It's HT. I was right. Oh dear. Oh, and a missing new line. Let's just put that in as well. It's rather picky, is this compiler. I stick my tongue out at you. I make the raspberry noises. Sorry, for everybody who's watching, that down there is where the chat is. Absolutely, they look wrong, particularly height. I mean, come on. English is just evil. I mean, maybe the English are just evil as well, but that's a different matter. Right, we have something that compiles. Compiles is good. So with that in mind, let us go and commit things, add the C and H directory, and just see whether we actually can build this on the build server. The skeleton scubs. I think Newspeak is far more prevalent in the US at the minute than over here. Right, push that, and then we'll have a look to see whether it actually built, shall we? Lack of coffee is definitely a thing. Lack of coffee, yes. Lack of coffee is definitely a thing. I've got my tea here, and I'm working my way down it very, very quickly. It built! Hey! Okay, so it doesn't do anything useful, but we got the G context library, and then we built it, and there it is, all nicely built. Woohoo! I still haven't added in that locale thing. I need to refresh part of the build service because it's I've got some new bits to come in from Pyro that I haven't done yet. There's so many things I'm behind on this month. I haven't done a Pyro release, and I haven't got any of the bits that I wanted to get done because I was playing with other things. Yes, and I was making fancy sci-fi buttons. They look really nice though. I like them anyway. Right, so what we got here, we've got a get size and a create function. Now, one of the things that this does when we come down here is it creates a scale object. Now, as I remember, I've got a whole bunch of routines for handling the scaling functions. Scalings and transforms and all that jazz. But I'm trying to remember where they might be. Because obviously they're very useful. Very, very useful. I know I've got them in Python, but I took them from the Python. I created them in the Python based on some other ones. Let's do a locate and have a see. Transform would be the name I'd use. Oh, it'll probably be image file render. It'll be an image file render. Export image file render. that looks like it's a quite like. In fact, if it's in there, then and that's probably the $exports head export slash missing file. Okay. Oh, export. There we go. Oh, you can't do that. Oh, it's the interface directory. C export. Yeah, that's. No, that's not the right one. I have no idea what these variables are anymore. This is not very helpful, is it? Libdir. There we go. Libdir slash image file render. I'm actually not going to. Oh, it's just got a transform object, nothing else. Oh, that's not quite so nice. Miscos Tech was using my sci-fi things, sci-fi, whatever they're called, icons. And oh, Spanners did create a rather nice artworks of a quality dial, which went up to 11, which was quite fancy. It was very nice, actually. So maybe that's not the one I was thinking of, because I thought I did one with a bunch of scales and things in it as well. Oh, let's find the code. It's easier. Subler / projects Riscos modules Riscos source, not desktop, video rendering image file render. Yep, that directory, please. Okay, so in here we've got the transform file, which has some basic transforms, apply to bounding box, multiply, classify at what type of bound thing it is, but it doesn't do any scales. We haven't got scale one in here. That's odd. I thought I had one that did that. What about my draw file handling? This is Justin root sources graphics. Not graphics. Library. C libraries for draw. Let's have a look at that. C libraries for draw. We've got bounds object there, which handles different bounding boxes, but doesn't handle scale factors. Hang on, let's go to the header, just check if there's anything in here. Angled things, scale, there's a scale factor, but it's a doubles. How weird. All right, do I locate scale? Is there a scale? Oh, toolbox libs, that doesn't help, does it? Yeah, not toolbox things. Scaling test. Well, this is all very disappointing, to be honest. Although, image file gadget, doesn't that have the ability to do scaling? Only it just passes things through, doesn't it? I'm a little bit okay, fine. Let's move on. Let's just go and implement things. Serialization routines. I want to pinch that code at some point. That's a nice file. Yeah, because that does all those things, doesn't it? Yeah. I'm going to pinch that and put it somewhere. That's a problem for another day, because I think that is what I want to use as my in part of the rendering system. in G context, but not for draw files, but for, well, actually we could do it for draw files, but also for draw paths as well. For another day, so this is my transform code that I've got here, which is fine. If I have a look in Veneer, because I think Veneer we could pass in scales, couldn't we? Yeah, so there's a scale there. There's my scale. But I didn't put that into a separate thing, an identity scale, a transfer. Oh, and then I do the muldiv to calculate it directly. How irritating. Okay. It's the handy thing having lots of sources of various things that you've written over the years. On the other hand, remembering where you've put them is apparently difficult. Yeah, so yeah, we know that this transform code is actually useful because this is actually not a bad thing. So let's go and just put this in here. New file, transform. Oh, except I'm not going to need transforms, I'm only going to need scales, aren't I? Because we're not going to be rotating sprites and things. Well, let's get rid of that then. We're going to have to just do the scale ones and do that as a... Oh, right, okay. Okay, let's just create it. I feel sad now that I'm creating something that I feel that I've already created, but no matter. Scale. If it turns out I have created it, then we can always go and merge them together at a later date. And the way we want to do this is, hang on, let me pull this up here. So this is Pyromaniac again. If we look for graphic structs, there we go, graphic structs. This is all the classes we would ever need, I feel. It does a lot of things. Oh gosh, it does a lot of things. And it returned, oh, I'm gonna have to. All right, let's just implement this from scratch and then we'll work out a way to integrate things together in a later date. All right. Yeah, I'm sure we had some stuff. Dave says we had it in ePage too. That's probably one of the things, because obviously spent a reasonable amount of time working for Pixel as well, so it would have stuck in my head. And a lot of the things in Pixel in ePage's systems were very, very similar to what we would have used in Riscos, because it had a lot of that lineage. Okay. Again, this has almost certainly been implemented before. I can just pinch one of the bits of code though. Where was the? Because we had a scale object, didn't we? We had a scale object in here. Yeah, there's the scale object. I'm literally just pinching it and then going to change it. Scale S. Scale S. Oh, scale T, sorry. These should be in 32 T's to try and keep them to the same object size on both systems. Oh, I'm in a C file at the moment though. I'll move things around in a second. If we just pop back to the other files, is there anything here? Get clipping rectangle, get transform. No, but that is the scale to transform matrix, and we don't need that. We don't actually need those at all. So wow, I've only copied just the tiniest bit of code there. That is rather pointless. Yeah. Well, that was a little digression for 20 minutes looking for something that we couldn't find. Hey ho, no big deal. Right. Seriously, I'm sure I've written this. Scale underscore apply. I swear that something like that would have existed. In the export directory. What was it? Lib. No. How? That's really bothering me now, because I swear I've written this. I have written this. I have written this. Was it for Doom? Was it for the renderer in Doom so that the Doom sprite renderer could be handled that way? Projects, Riscos. It would be in the Doom game, I guess. No, that's not it, any of it. Oh, although that is, iSprite would be the part of it it would be done in. Just have a quick look at that. You realise this is not actually saving me any time whatsoever. Oh, these could be handy just to pinch at some point. Yeah, there we go, scale structure. Scale dot, or scale dot, yeah. See, it's not especially, a lot of this stuff is not complicated. I'm going to leave this one down here as well. I'll have lots of files down here that I can just go and pull up and go, I'll pinch this bit, I'll pinch that bit, and then I'll never use them. Right, let's define a scale apply to accords. Scale T star scale and accords T star accords. Accords dot x equals scale. Also, these are not dots, these are twos, these are pointers. And this should use div mul. Muldiv, sorry, instead of calculating directly. Because this will fail otherwise at high scales. But for now it will be just fine. We'll go with apply to scale there. That's it really, isn't it? That's all you need for that. All of that time wasted on just a very, very simple, this is what we're going to do as a function. I mean, how pointless was that? Really, really pointless. Scale that. Oh, we should define this as a scale apply scale factors to a coordinate pair. Actually, it's also handy to be able to apply it to a bounding box. Oh, I didn't even define the variables. That's useless. Scale to scale. Scale points to the scaling block to apply. Coordinates to update with the scale. Yeah, none actually, we're not referring to it. And then actually this is the same thing, but it's for a bounding box. scaling block to apply the coordinates to update with the scale. Remind me what a bounding box looks like. I've already forgotten. Oh, it's in the G context, isn't it? Viscous kitten C:(G context dot H dot G context. Yeah, that's right. X0, right, obviously it's going X0, Y0, X1, Y1. Bum, bum, bum. So that's very similar to this. X0, Y0, box 0, scaling. Yeah, that's right. Now copy those lines. Oops. That didn't quite do what I expected, but it's actually come out quite well. And we do the same for X1 and Y1. Okay, there we go. All right, so those prototypes can now be created in the header file, blah, blah, blah. And I also want to hash include gcontext/gcontext.h. There we go. We've got that as well. And we don't need the implementation there. And we can just make this include the new file. Are you bored yet? Scale can be const too. It can, you're right. That's a very good point. Scale. Let's go back to there. Because that's not the one we're modifying. And same goes in here. Always pain getting the const right, but if you're not modifying, it does make things a lot easier because you can more readily reason about things. And more importantly, the compiler can more readily reason about things. Be quicker for me to type it. There we go. Let's see if this compiles. No. Non-formal scale apply. Line 19. That probably means I missed a semicolon from my header, which I did. There we go. And we got it compiling. Woohoo! Right. So now we can go over here and we can actually start implementing this one. Probably. So what we got here, this is a, that was get size, this is get scale, isn't it? Right, so get W's, what are we naming these? Wimp Sprite is what we're naming them. Wimp Sprite get scale. Need the scale factors to use for a given sprite. Okay. That's the thing, and we're going to return a scale t. And we take in a Wimp Sprite. W Sprite. Wimp Sprite to the sprite we want to size. Not to size, to scale, to get the scale of. So this will tell us how much we need to scale it up or scale it down or whatever. What do we do here? We do this stuff. It doesn't look particularly nice. So we have a scale t to begin with. X pixel size is that. So let's just make that into an int. Render x pixel and render y pixel, that's the size of x pixels on the screen, and that's going to be in W Sprite to graphics to x pixel. Oops, there should be semicolons, which we don't actually have yet, so we'll need to define that. And sprite x pixel is getting the eigenfactors and scaling it. So that's the size of a pixel on that. Actually, we can call this here, get the eigenfactors. Get the eigenfactors into there, and then we can define the sprite pixels. Oops. And sprite x pixel, y pixel, ints, one shifted left, s eigen dot x eigen. Come on, dots. Thank you. And if it's half size, then we pretend that the screen is a higher resolution by doubling the render size, so it will divide it down more, which is a little confusing, but yeah, it makes sense. So that is if half size, so it's if W sprite 2 is half size, then we just want to double those. Bum, bum, bum. Now, so this is saying it's an identity if it's that, otherwise it's this. So we may as well create an object that is identity scale. Identity. Scale identity actually should be, shouldn't it? Equals 1, 1, 1. This is where I'm wondering if having it as a object scale to and passing them back by that is going to be a good idea, because actually null is more efficient. It only takes a few instructions just to check that. Yeah, that's not terrible. That's fine. Scale identity. There. Otherwise, this is going to be, we create it scale underscore. Oh no, we not C, not Python code to begin with. Let's try doing this as C code. And or then it goes to identity. Otherwise, scale equals s, no, scale.xmult equals that, and there we go, we've got a scale block being returned. Cool, all right. The only thing I need to do now is to make sure that this graphic structure actually has something we can look at. So I'm going to have to define some bits in here. So in Wimp Sprite, graphic structures now going to have to start getting some structures in here. So we need int x pixel and int y pixel, like that. Okay, those are the only things we need right now. And we probably should annotate this. OS units for an X pixel. And that's a Y and Y. Yeah, that's right. Okay. Oh, we didn't include the scale H, did we? So it won't know what any of those types are. Let's include the scale H. Scale.h. Command but found int 160. Inventing self. I clearly haven't quite got that working yet. Oh, and I defined the identity here, but I never actually made it an extern in here. So what we can do is just do that extern there, so we can actually get to it. Right, what we got in here? We got some self somewhere. Self. There it is. Yeah. So that should be W Sprite. Unscaled. Sprite X pixel. Oh, I redefined it with ints there. That's why it's not liking it. Okay, let's try anything else. And I missed a semicolon. Mr. There. Boom, boom, boom. Undeclared int Sagan. I didn't declare it there. Sagan factors. Sagan. Is that not spelt the same way? Yes, they're spelt the same way. They've got boxes around them. .116 is failing because of Sagan's that. Oh, that should be the way that's spelled. That was what it was complaining about. You have to read the error message. I mean, They were dots, not twos. And maybe used before being set. How might it be used before being set? They're set here. Oh yeah, it must have been just the warning about that broke it. So yeah, if I'd looked down at the chat, I'd have seen that David pointed out it was the spelling that I'd got wrong. Silly. Right. Now we've got some scaling factors, and that function is now complete as implemented. We still haven't got all the skeleton to go around it, but we've got some of the code. So let us commit this, add C and H. Go. Right, and we can push that as well. Okie dokie. I think we are due for a little bit of a break because it's now just coming up to 2:30, which is good. And then we can move on to the next bit of the code because we've got get scale implemented. Next is get PixTrans, which doesn't do anything, but we'll start implementing that from the Riscos side of it. We'll make it work. All right. So I hope this has been interesting so far. We're going to have a 10-minute break and then we'll come back. All right. So far we have got some bits working. What I should do is check that it's built. Check that the automation actually built it. Yep, it did. We're all good. Nothing wrong. Only took 18 seconds. Nice. Yeah. And we'll come back and we'll have a little bit of a attack at the Riscos side of it, rather than just some values being plotted on the being worked out in maths world. All right. See you in a little bit. Bye. Hello again, we're back. Excuse me. Continuing with sprite rendering code, basically trying to get the bits we've got set up so we can do some sort of rendering just to draw simple sprites. So it's going to be a bit fun. But hopefully we'll manage to get somewhere with it. Let's just stick some dummy values in here so we've actually got something that's going to kind of work. And then we can start actually calling things on it. So we're also going to want some pixel translations and some rendering code, because the rendering code is kind of important. Let us find the Pyro code that actually did that. And Wimp graphics, here we go. This is the Wimp graphic structure. Wimp, Viscous Wimp Sprite. This is the one. This is the specialization for the Wimp. So get pixel trans is our next function, and then we've got render as well. Whoops, got a bit far there. Yeah, there we are. So let's grab that, and we'll try implementing those bits. All good fun. Right, next bit. Again, I'll go and just leave this commented out so that we don't have it looking funny coloured and stuff, and confusing my compiler as well. Right, so this is going to be Wimp Sprite get pixtrans. So eventually we'll have a bunch of pixel translation, caching and all the rest of that, but this is where you actually get the particular pixel translation for this sprite, and the pixel translation handling would be handled somewhere else. It's not implemented in the Python yet, but we would do it that way. That's sort of how it's handled in the Wimp as well, in the classic Wimp. So let me just sit a bit further across, that's a bit more comfy. Right, so this takes a Wimp sprite. And it doesn't do anything else, it just returns us a pixel trans. And actually, yeah, this is interesting because it's going to have to return a block for it. A pixel trans and a plot action. That's kind of frustrating, isn't it? So what we'll need to do is we'll need to have probably a pixtrans structure we can actually return this through. Because golly, there's going to be a lot of things here. Type def Wimp pixtrans s. I'll say struct. D. Right, so the pixel translation is going to need what do we have? We had the plot action, yeah, and then there's the pixtrans data. So pixel translation data can either be present or absent. And if we're going to make it possibly absent, then I probably want to have a Alan says, well, since he heard somebody say, oh golly, I will try and say it more just to make you feel that it's back in fashion. No, that's not true. I would never make something fashionable. Yeah, anyway, I will just phrases. All this sprite saying got me thinking about custom scales in emulators. It'd be fun to have some of those in sprite scales. I can't think what API you'd use to select them. This is always a fun thing, yes. If the interfaces were a little bit more flexible, we could do things more easily. And restructuring some of the graphics interface is something that, once the things that are using it are less tied to what we've currently got, the easier it could be to try and handle those. So that's the sort of direction that I'd like to go with it. Plot action is an int 32t actually. because this could be null. Yeah, void star pixtrans, and then actual pixtrans data would live here. So we could allocate a block that contains these, and we're going to do that. So we'll try this. We'll try this. Let's see what we can do. So we're going to return a Wimp pixtrans t star. This is going to be quite difficult. I'm thinking this is not going to be easy. So int data2t plot action. I'll keep the variables the same naming scheme. And that should be 0 initially, and we're going to need to allocate a Wimp pixtrans, but we're not going to have anything that's valid there. So initially void star pixtrans is going to be null. Oops, I forgot to put the 0 on that. Pixel translation tables. If the sprite's log 2 bit per pixel is 2 and we don't have a palette, how are we going to do that then? Let's no need to get, we just have a log 2 bit per pixel of W sprite and not sprite as palette. So a lot of these things we're doing here, we're reading them out as we need them, but we can cache them in the future. Maybe. We'll just have to work out the right way of doing it, but I think there's a bunch of ways that we can handle this that will be useful in the future. So if that's the case, then we say source mode is 27 and the palette is one of the standard palettes. So I'm going to need to define the standard palettes, so we're going to define that shortly. We're going to need a Wimp. Oh, hang on, we had a Wimp palette object, didn't we? We had a Wimp palette object. That was in text rendering, which is down here in my collection of windows I've kept off screen, which I've apparently lost. Did I close text render? Oh, come on, please didn't tell me I didn't close it. That one's Pyro. Image file render. Draw. Sprite from Droom. And that's it. Did I want to check in the other window over here? I'm not seeing it. I must have closed it. Well, that was silly. Alright, well, let's pull it up again. Move these out of the way again. Text render. Oh, I did a B compare on it. That's why I didn't open it as a subler. There we go. Let's put it as an editor window. Palette. There we go. And there's the Wimp palette code, and that has the regular colors, the border colors, and the pointer colors. And there's also some palettes for the other modes as well. Well, let's just, should I just copy that for now? That's kind of the right thing, isn't it? Because that's what we want. Oh, yeah, we'll just create a palette file here. Palette, because we're going to have to create a whole area of handling palettes anyway, because they've got a bunch of operations in them. Oh, and I'll just copy the header file as well. Just give me a second. Yeah. New file. Strictly, this should probably be Wimp palettes, not just palette, because it's specific to the Wimp palette we're dealing with, but maybe we'll worry about that later. Okay. So the thing was, if it doesn't have a palette, then source mode is 27, and source palette is, oh, what was that palette called? Current Wimp palette. Actually, shouldn't that go through the graphics context? Probably should, shouldn't it? That's interesting. Yeah, so in which case then, for now we'll just use current Wimp palette. Also, let's leave our fix me note here for this one as well. Boom. Oop, no, didn't want to copy that bit. And the other bit we had there was an important one, was this, so just describe what we are doing. Copy that as well. I'm trying not to race through this so that it's vaguely readable. And people can hopefully follow what we're doing. Right, other depths use the sprite's own palette to reference it. I don't think that code's quite right either. But just copy it because that's what I've got at the moment, and then we'll be able to fix it up as we find problems. Source mode is 256. Flags here as being this. Now this is kind of fun, isn't it? Some magic values here, so they've surely got to come from ColourTrans. I wonder why I didn't use like proper values, because I mean that's not very good, is it? So let's actually just leave a note here for myself. So here we go, in here. This is the same comment that we had in the other code. It should be read from the graphics context. And these shouldn't be magic values. So these are being passed into generate table. Actually, they're not. What? We're actually not passing the same flags through. That's a little weird. That is a little weird. Yeah. Now we'll pass the flags through properly. That's better. But I still don't have those flags in there. Do we have some constants? ColourTrans? No, we don't have any constants for ColourTrans. That's really frustrating. In which case then let's have a look in ColourTrans.py. ColourTrans constants, here we go. Table flags, these are the flags we're interested in here. So we've got given sprite, given transfer function, and wide entries. Those are the ones that are mattering here. So let's pick those up. I mean, I'm assuming that we don't have one of those in. I just have a look. I could have done it out here, couldn't I? ls $C export lib. Riscos, do we have anything in there that looks like ColourTrans? Oh, in there that looks like a ColourTrans file. No, that's coming out of interface. And this one, no ColourTrans file there. Not very nice, is it? Yeah, that doesn't have ColourTrans either. It's just not exporting these constants. Very irritating. I probably should have done that. No matter. In which case then, let us copy these constants here. Copy. Since I'm copying the ColourTrans constants, copy them from here. These are actually the same constant values that are used in oslib. So yeah. Dave says the Viscous Sprite system is the definition of combinatorial explosion. Yes, and I guarantee you that there are cases that will blow up in stupid ways when you put them together, even with entirely valid code, because it's just too difficult to get things right. I spent a lot of time, I can't even remember how long, but I must have spent weeks and weeks going through Sprite Extend, going, okay, if you put all these flags together, how can it render? Oh no, it blows up, and it tells me that this is the reason it's blown up. It's run out of registers, because the Sprite Extend renderer uses a JIT that goes and generates ARM code that does the rendering for you. And so when it runs out of registers, you have to go and rejig the code so it pushes things onto the stack and moves the loops around and things, but only in that case, so the other cases don't get less efficient. And once I started introducing the color mappings and transparency, that really started to multiply up, because obviously transparency is, I want this to be like 50% opaque. That suddenly is a big deal. And you have to not only handle the palette translations, but you have to handle the original and the screen source. So there's a whole lot to be done, because you might have a 15-bit color sprite being rendered to a 32-bit screen, or a CMYK sprite being rendered to a 15-bit screen, and you have to apply some sort of transformation on the CMYK and on the transparency, and then maybe you've got a color map being applied for a transfer function as well, which means it has to go up to be 32-bit color in the first place. Oh my gosh, there's a lot of combinations. And that's before you start thinking about it caching them as well, because when it cached them wrongly, you'd try and do one of them and it would come out with something else, which is not very helpful. Anyway, what I was saying was these are actually the definitions that are used inside oslib. These are the oslib definitions for them. So were we to switch over to using oslib, it would become very easy. This is ColourTrans constants. Oh dear, if no def, oh dear. I've got an arms there. You know, I could have just copied the string, couldn't I? Meh, not a big deal. Right, hash space is replaced with // That gives us some comments. Good. Get rid of that. All of the lines that have got equals should just become equals. Yeah, just make them a few spaces. I think we'll do the job. There we go, like that, and then we add in some bits here that are hash different. Oh, actually, we can do this. Yes. Start of line followed by at least one space followed by a capital letter should become hash define space and then that letter. And then replace. There we go. Oh, that one didn't work. Oh, because I used a C, didn't I, rather than an actual capital letter. Fine, there we go. Actually, what I can do there is just do that and it'll get rid of all. There we go. So we've got all those things defined. Yes, some of these won't line up. There we go, they're now nicely lined up. There we are, lined up there, they'll be fine there. It's a font file, font handle. I think we're probably good enough here. I don't think we're going to really want to worry about it too much more than that. Right, there we go. So that was my ColourTrans constants. There's no types in there or anything, but this gives us some values. So we can now go and put them into. No, I didn't want to move that out of the way. I want to leave that there and copy the values. So ColourTrans given sprite is 1 shifted left 0, and 1 shifted left 4 is wide entries. So that's got us all the way down to here. Column map func equals null and color map workspace equals null. This is wrong, because the color map function may also need to be returned if it's a true color sprite. Oh, so that code is actually not correct, but we'll just have to worry on that in a moment. Workspace, if WSprite is selected or is shaded, apply the selection / shading. So color map func apply Wimp color map strictly. Sprite to is selected is shaded, and then the background color, which is WSprite to window background. There we go. Fix me, this should be implemented as a color map descriptor. And we're not going to implement it right now. Just note that it's there. Oh, and of course we need to set the flags as well. So flags or equals. Which one was it? Sorry. 2. Oh yeah, transfer function, that's the one. There we go. Right. Generate table is the next thing. So this has all been done to here. So we want to do this one now. This is the generate table to get the size. So think we're going to just actually have a function that does this work for us. -1 that is, they've got special values here, haven't they? They've got values of the current mode as well. Yeah, current mode there. We'll just move that up to the top. So we can have, it's not actually current mode, it's actually current destination, I believe. And this is current palette. Output is none, which is implicit in this, and then flags. There's flags there. Oh, except I should have copied this down to there. Like that. Oh, except I want to table size equals. And then we need to get ourselves some space and then generate the table into there. And we're going to actually return it with the whole block here. So our Wimp Trans T WPix trans equals, check for error. Yeah, we're not going to get as far as actually rendering anything today, are we? We're just going to end up writing a bit of processing code. Maybe next week we'll get some rendering working, shall we hope? We just hope that, yes. Wimp Trans is a mallet block that is of size Wimp Trans plus whatever the table size was. So it should like fix me there. And check for 0 table size being no table, because we might not need a table there. Probably will though. Don't know. We'd have to think about how that works, but that's what we need to do. So then we get the pixel trans. If WPix trans is null, return null. Sprite we wish to render, and that's it. And we return pointer to the Wimp Trans T for the table. Or null failed. Oh dear, I'm getting a bit tired now. So unsurprising, I suppose, since I was up till late and doing stuff. That's wrong. That's not the right thing, is it? So we want sprite actually, sprite address is just sprite w sprite to sprite. That is the address of the sprite. Actually, let's make it very clear. Sprite address, and that can be an identity function that just returns the sprite handle itself, sprite pointer itself. Right, so we've allocated it. Now we need to actually go and do the generate table. So it's the same as this call we had up here, but with some other bits. So we've got the source mode, source palette. Again, we can take these two here to be current. Output is the PixelTrans buffer, which is WPixTrans. WPixTrans to PixTrans equals char star plus size of W. Oops, that should be a star size of it. So just shove it onto the end, and then we can actually do PixTrans to PixTrans. That's the output. Flags is the flags. Transfer function is going to be color map function and color map workspace. There we go. That's the call. And what do we get back? If failed, we're not returning Wimp error blocks here, so we're just going to return back a failure state for this, just to be very simple. If it failed, return null, and of course free the block we allocated. So this is going to be inefficient because it's going to be allocating and freeing the blocks, but what we can do is we can make those cacheable later. What are we going to do here? We've got that done. The next thing we need to look at is, yes, we allocated the table. That's all done. This is now done. If we are currently in a deep mode, then we got back a wide translation table. That's fair enough. But we can get that information from the graphics context. Get this information from Wimp graphics context. If we're doing this right, then in theory you should be able to not render to the screen, but actually render all of your Wimp sprite operations to another sprite, and then have the graphics essentially back buffered. So you could actually do the rendering of the window as a sprite operation that plots to the screen, and then we could have them all cached and running through a acceleration system. So you operate on an off-screen buffer, and then it gets blitted to the screen, which could improve our performance in some ways, but it could also mean that you never have to page in a window that is not being redrawn. It could just be handled separate to a backing buffer. Again, that could also be something that's a flag for the window to say, I want you to do this. Again, these are things we can try and look at in the future, but we need to keep these things sort of in mind as we work through it. If W sprite to graphics to render log2 BP is greater than 3, do we think we've actually got wide present in anything? Grep for wide in libdir. It's in oslib, unsurprisingly. Is there actually anything in the C? What was it? C export, wasn't it? No, nothing else there. That's a little bit sad, isn't it? Yeah, okay, so we'll just have to define that one temporarily. Just happens that given wide entries is shown up there. Just give me a second. This is the sprite constants for this. Actually, does that mean that, do we have C:(h dot sprite? No. How about capital sprite? How about in the Riscos area? Yes. Oh, but it doesn't include anything but the boring standard things. That's no use, is it? Sigh. Oh well, we'll just have to copy this bit. Bits we care about are these ones. New file, sprite constants. Really, these things should be all in standardized headers that we always deal with. That would just make things a lot easier. But yeah, I've not done it, and I imagine it probably has been done in Riscos 5, and I should just pinch those bits. If ndef sprite constants h, or I should just use oslib. I mean, that's why it's there, so you've got all these things defined and you don't have to go and jump around all over the place. Oh, really? That's an hour since we did our last break. Okay, snooze. It's 3:20. 40 minutes, then we'll be done. Constants. For use with sprites, and we're going to use this in conjunction with include Riscos /h/ oh, what was it called? I've forgotten it already. Sprite with a capital S. There. Okay. So in here we should be able to include sprite constants as well. Oh, include ColourTrans constants .h and include sprite constants .h. There we go. Sprite.plot action, wide translation present. Thank you very much. So that is the last of the things we need to do. So all we need to do now is just go wsprite to, sorry, not wpixtrans to plot action equals plot action, and then we can return wpixtrans because we've already updated the pixtrans value there to point to it. Okay, so that gets us all of that done. Of course, I've got a bunch of functions here that are not implemented. So let's just have some quick definitions of these. So int table size, let's get table size. Source mode. Oops. Void star source palette. Again, this is uint32 dest mode star dest palette, and then uint32 for some flags. Okay, that gets the table size. And then the other one here is generate table. Copy that one there. And this returns a boolean to say whether it's successful or not, because that's the way I defined it. Maybe this shouldn't be called generate table because it's not quite a direct interface to generate table, but it's okay. Oh, sorry, I meant wait for half an hour, please. Thank you. Void star output, then the flags. Maybe I should swap flags and output around. That would make things a lot easier, wouldn't it? I'll leave them as they are. Void star color map trunk and void star color map workspace. There we go. So those are just some little functions that we're going to stub up in our stubby action. A stubby action? A stubby section. Can't speak. Right. Get table size. Return 16. Generate table. Return success. There we go. Wonderfully implemented there, aren't they? Bum, bum, bum. That's right. Yeah. Oh, excuse me. Oh, gosh. Yeah, my brain's clearly going to sleep now. Define sprite underscore address. Sprite to be sprite. It's just an identity function there. Is that everything I asked for? No, I've got log 2-bit per pixel and has palette. So we'll just define some for that. So int log sprite log 2 bpp for a sprite turn 2. Now we'll turn 1. And what's the other one? Has palette, wasn't it? No palette present. Oh, that should be a bool, sorry. Right, should we see if we work? Should we see? Well, not work. We'll see if we build. I mean, yeah, this is all stubbed so much. There's not. It's not going to actually do very much. It's not even going to compile. Oh, I never defined any variables, did I? Yes, 186. Pixel. What are you failing on there? Wimp Sprite T. Hang on, didn't I? I thought Wimp Sprite T was what we were using up here. Wimp Sprite T. Oh dear. Yeah, this is why keeping the names the same is good. Right, all of my variables are not defined. Missing new line before end of file. Yeah, okay, fix that. Right, so let's define some variables, shall we? Source mode, void star source palette. What else? Some flags. Uint 32 flags. A color map function. And a color map workspace. What else we got down here? WPixTrans. Oh, is that was already defined there? That's good. And the plot action was already defined. Okay, so I think that's all the ones we needed. Let's just have a quick check. Wrong number of parameters. Oh gosh, I must have missed something. Source dest. Source dest. Pixel translation. Flags. Color map function. It looks right to me. Okay. Where's my stub gone? Source dest, source palette, output flags. They look the same. Let's see if see where we get to now. Current Wimp palette. We haven't included palette.h. 205. Should have been ampersand in there because it's a pointer I want. Mr. Semicolon on there. We missed a semicolon there. Yep, that's fine. Next one, table size. Ah, yes, we're doing table size. There. Is that just because I've forgotten something? Let's see what we get to now. 228. Implicit cast of non-zero int to pointer. That's probably this thing here. Needs that. 239. Yeah, same thing. Probably twice, one for each of them. How old was I when I started coding? Primary school, certainly. Yeah, not sure. So yeah, coding properly was probably penultimate year, or possibly the year before high school. When do you start high school? Sorry? 11. So if it was penultimate year, then it would have been 10, 9 or 8, probably then. But then I didn't actually get quite so serious on programming until really got into high school and started doing things more interestingly. That was with a BBC Micro, writing in BBC Basic, and then 6502 assembly. I did lots and lots of very weird things. So we had a strange printer, and we had a copy of, oh gosh, what was it? I can't remember what it was, but it was a really quite nice AMX PageMaker. It was AMX PageMaker, I think, and I think it was anyway. You could design some wonderful pictures on there in mode 0 and mode 2 or something. I think it was mode 0 and mode 1, but it had no printer drivers for my printer, and so one of the earliest things I remember writing was the printer driver code in assembly that would take the screens and allow it to scroll the screen up and then do the next one. And I basically coded that just so that we could print things out to our really quite special printer. We had a Tandy printer, GMP 105 or something. Nah, that can't be right. I can't be remembering that. Tandy printer. Oh my gosh, it looked very much like it. The GMP 130. Okay, well, go on, give us a picture. You gonna do it? Wow, this is exciting. Looking at a black screen, we really enjoy that. Yes, that was our printer. And the printer manual was this manual. I don't care about withdrawing. It has this manual, and it had, oh, not that one. Come on, give me some pages. The codes you had to use. So for each of the dots, what codes you needed to use to print them, and how you could set it into different density modes and everything. All these, all written in like Tandy Basic, I'm assuming it was, and I had to convert it to initially to BBC Basic and then do a whole bunch of things. It was a really nasty printer because if you tried sending data to it too quickly, the BBC just backed off and then it would come out so slowly, and we had to buy an extra 32K buffer for it so you could send data quickly to it. Great bits here. Like, oh yes, even the manual didn't actually have valid code in it. It's really bizarre. And these codes were not the standard Epsom escape codes that you would generally see in the day. The different pinouts on it and things like that. As Andrew says, this was the days when manuals were actually useful with real data in it. But this was one of the things that we wrote, and then about a year later or something, after this, Repton Infinity came out. I'd done loads and loads of things during that time, written some games and things for us, some games that you actually find online as well. Very terrible. So Repton Infinity came out, and I really wanted Repton Infinity because I loved playing Repton 1, 2 and 3. And Repton Infinity included a programming language in it, so you could actually tell every block in the game how it should react. So boulders would go and fall if there were spaces to the sides, and you had rules for spirits that would run around and things, but you could make them do anything. You could make them do all sorts of things. And one of the things I eventually went and implemented was a nice version of Icicle Works. Icicle Works was a Commodore 64 game that I really loved, and I had lots of versions of that we worked with, and other sorts of games as well. But we ordered it from one of the local computer stores, and they ordered the tape version. And I was like, I want the tape version. I wanted the disc version. And I was really upset. And we went away, and I was really upset at it. And then I was upset at myself. And so I told Dad, right, I want that. I will make it work. And so we bought it, and I played it on tape a few times, and it's like, this is too tedious, because you basically had to, each of the parts of it had to be loaded off tape. So you had to load the graphics editor, and then you had to load the map editor, and then you had to load the sprite editor, and then you could load what was the other one? Oh, the actual code editor that defined how things worked. And then you had to load the linker to link them all together. And it was impossible. So fortunately, we had a disk drive, and we had sideways ROMs on there, so sideways RAM. No, it wasn't. Well, it may have been. I don't know. It was the school things. But we did have a Watford Electronics sideways RAM board, which had 2 banks of 16K of sideways RAM. And that meant I had an extra 16K to play with, and I already knew how to implement ROMs and the like in ROMs, as in the implementation of the interface to do that. So I could write little basic code that would go and do this. So the problem with the tape Repton Infinity was that it assumed you had a tape. So all of the memory that would be assigned to the disk in the addresses E00 up to 1900, it was using for the game, and I wanted to be able to play these things. So I wrote a rather interesting memory flipping system, so that what it would do is the game would be copied from sideways RAM into memory for some of the operations, and one of the other banks would be used as swap space. And you'd have most of the games, the binaries for the map editor, the linker, all those bits were on disk. And it would load the part that was high memory above 1900 into the memory of the BBC. It would load that into the sideways RAM, and then it would load the bit that was into low memory into the memory above that, and then it would shift it down over the top of the memory that was used for the disk, and it would swap that at the same time with memory that was inside his RAM. And so basically you flipped out the entire disk interface temporarily, and then you ran the tape version, and then when it was ready to load the next binary, you then switched out by flipping that out and flipping it in, which was all kind of complicated, but the upshot of it was that I had a version that was the disk version that actually worked interestingly, but was actually the tape version, all running from disk, and you could save things and load them and all the rest of it, and you just had to press break to switch between the different editors, which was quite fun. It was not the best way of doing things, but it definitely worked. Later, when it came on for, I don't know if anybody remembers, dummy dynamic areas. Dummy dynamic areas was a way of faking dynamic areas on the A5000 and other systems by manipulating the page tables that are used by the RAMFS, because the RAMFS was a dynamic area that you could resize, and you just could use standard calls to do this. All of which was quite easy because I'd already done this bank flipping thing for Repton Infinity. Oh my gosh, I'm sad. Yes, I'm very sad. I'm sure. Oh, I thought I'd posted Feud up to one of the game sites, but I could never spell it as well, which may actually be the problem. BBC game. Gerph. No, that's not right. Ah, well. Oh! View loading screens. Find. There we go. Oh, look at that. In context, please. There we go. That was one of my BBC games, Feud. So you could actually like play against your brothers. And these are games that we maps that we created and played together. Oh, animated version. Oh, let's bump the size up a bit. There you go. That's my little man running around and collecting spells. Oh, this was my version of the C64 Commodore 64 game, Feud, which was way better. But so one of the players would play on the keyboard, and one of them would play on the joystick. And the joystick was we used a Atari joystick that I had wired directly into the user port, so you could do things. Yeah, it was very very fun creating that. And as you can see, it's not a particularly complicated game. Oh look, I'm firing little lightning bolts. You've got little spell books here that you can flip through to get the different spells and things. It was I loved that game. It was lots of fun. It's showing you collecting the herbs, and then they appear back after a little while. Oh yes. Sorry. Lots of fond memories. Oh, that's a little bit large. It's a smidge large. That. Let's reset that back to there. Yeah. Oh, there we go. My old address, Justin Fletcher, in the Green, Coddington. My Explode game. I like my Explode game as well. Early games, the later bits. Oh, I did a version of Civilization as well, because you have to do Civilization. There we go. There's Civilization running on Riscos as a prototype there. Yeah, very, very exciting. Oh, animated version again. Oh, there we go. So you can move yourself around and place things on it. And the little mini map goes and updates as you can see things. It tells you can't move there. And all the I was really pleased with how well this worked, but it was something of a long project of like a few years. The original version was in BBC Basic and in assembly on the ROMs. And you can see selecting different things, and you can see what units are available. Units become available as you click on the tech tree. So this is just faking it to show that it works. And the BBC Basic one was actually had animation as well. It would the waves would come in as well, because we could do that. Again, that was long time ago. And then there was Mariah. I didn't port Mariah, but I did a whole bunch of bits with my automation on that. Some extra games, yeah, all fun. Sorry, I've been distracted by someone asking about when I learnt about things. Oh, good times, good times. Now I can't even write C code. I mean, this is just useless, isn't it? What's this then? So oh, I put a semicolon. That's why it's got confused there. Wimp Graphics has no log2 bit per pixel field. Let's go and add that into this one. Int log2 bit per pixel. There we go. Depth as log2 of bits per pixel. I think we're nearly done. Variable PixTrans declared but not used. 250. Oh no, not that file. This one here. Yeah, I don't need that one apparently. Current Wimp palette. Oh, that's because current Wimp palette is in palette and we haven't included that. O.palette. Yeah, that's linked. Cool. So there we go. We've got something that's linked. I think it's probably time to call it a day there because we're not going to get much else done today on this. Added routines to obtain a pixel translation table. All this code is still heavily stubbed. We'll add implementations shortly. There we go. We'll push that and we'll see that it builds. Whilst it's building, let me just have a stairway to no, what's it called? The BBC Games site. It goes straight to heaven. Straight to hell. Straight to hell. Has closed and there'll be no further updates. Well, lives there. The forums live there. You'll search the images. No. I'm sure I went and released it. Game release. No, don't know. Hang on, maybe. Oh, that doesn't help, does it? Because obviously, Justin Fletcher is a person. I I'm just sad now. I'm sure I did something with it. Did I make a viscous version? Usenet site. Feud. Oh. Oh. Oh, it's just a readme there, yeah, okay. Oh. Oh, don't do that. ROM loader. Some ARM code, okay. And select for Viscos. This is a Viscos archive. CMU. In case anybody's interested. The zoom level on the other one was awesome. I mean, seriously, it was just particularly on the Commodore 64 because it was so much like more than you'd ever expect for that sort of system. Right, let's see if we can get this into there. So just copy it in your window. / library application support, not Sublime. IPCMU hostfs mcderp vid probably the easiest thing is just to copy it, isn't it? I'll unzip it and copy it from downloads FUD3 to here. Yeah, Python Viscos unzip. That'll be what I need to do. Like that. Thank you. And then we can have a look in here. Oh, look at that. Right, I'm sorry this is not very big. There's no way to do scaling on this, is there? Settings. Oh, there's full screen mode. I'm not sure if full screen mode would actually work with it. Handle is either illegal or has been closed. Well, balls. Load mode 1. Load ROM loader. Dirt into that directory. And then, what do you mean handle is either illegal? On error ext err port string plus at line. That's how you do that. Okay, run. Okay, that didn't work. Copy that. Is that the first one it tries to run? No, it tries to run load mode 1. It's this one. There's a watch this little loaded together. Yep, that sounds like me. Oh. How do you copy in this? Control. Oh, I've got to put a C in there. Copy. Paste. Thank you. I do not know how to use 160. View screen. Because of course no line numbers on this. It does imply that it's done some, although it's in that directory. What's it looking for? So it's trying to read feud scrap. Oh, Oh dear, different. Let's just rename that. It's not using the. It doesn't have the stamps on there. That's better. There we go. Okay. That's a mode 1 loader. And then, oh, look at that! Colours in mode 7. Woohoo! And the games KLAZ, MH, J, and cast spell is that. Okay. So, oh, select a map. This one here. Where am I? Oh, I'm that guy at the top right. I hope you can see him. He's having difficulty walking around. He's having great difficulty walking around. Such good memories. Run all the way up here. This was always a dangerous one because if you got stuck up here, you couldn't get past the other guy and they could fire at you at will and you'd be like stuck. It was quite a nasty one. And this one here is a little closer to the other guy. So the other guy's up there sitting over his cauldron. And then you can't get out there, of course. And you can move the spell book left and right. So I'm moving the spell book right, different spells, makes you invisible, goes faster, reverses the other person, heals you, teleports. Let's go back the other way. Clone will send it's another weapon, so that sends a clone of you racing at them to kill them, and then there's lightning. That's another one. There you go. Anyway, that's the game. It's all very, very fun, but that works. I mean, yeah, just apart from the unzipping not working properly. And that ran on the BBC. I've obviously updated it a little bit so that it has some ARM code in it. So ROM loader contains alignment references. Okay. Oh yeah. So there was a different version, so you could actually put this in ROM and you could have it running on there. ARM code. Oh yes, this is the BBC code. It used to be. I used to have, so I had to convert things to work out how they should be written in assembler. Because all it was doing was just a quick way of calling the right characters to put the particular sprites on the screen. So each of the sprites change colour and then move on to the next one. But do it quickly because basic wasn't fast enough just doing even the right calls. Anyway, my old games. Don't you love them? No, I'm sure you don't. Back to where we were. It is definitely time to stop now. I've pushed those changes. So we've got that. Yeah, it passed its test, didn't it? Yeah, it passed its test. Good. So we'll have a look at that some more next week. And we'll have... Alan says, I hope you've got feud on your resume. Oh, gosh, no. This was all just a bit of fun. Thankfully, certainly shouldn't be anyway. Well, I say it's there for people to download if you want it. It's a little embarrassing. There's a whole bunch of rubbish in here for various things. PRM. What are those? Oh, example pages from the generated PRMs. So I could show them to people. That's what the Riscos 2 style version of the PRMs looked like for SWI vectors, software vectors. Looks rather nice actually. I quite like that. It's a good style. I do like that style. It's just very wasteful of space. That's really the only problem with it. Yes. So anyway, all done. We'll look at some more of this next week and we'll start adding in the actual calls to do things and print stuff, plot stuff on the screen, hopefully. And we can start looking at more complex things. The color mapping is going to be interesting as well. All right. Have a good Sunday. I hope you enjoy what's left of it. It's sunny here. And I'll see you next week. Oh, and if there's anything else that people want to see as well, do feel free to drop me a line or message on the forums. I don't tend to look or think back on my BBC stuff, but yeah, there you go. See you all later. Have a good... Oh, and of course, if you want to subscribe and all the rest of it, please do that and what have you. It would be good. Sponsorship on GitHub is also a thing if you're really interested. Don't think we've got many people, but what the heck. See you later. Bye.